Hi, and welcome to this video about the new advanced data generator. The data generator comes with a sample project. In this video, I will recreate this project for you. The idea behind the sample project is a database for a small web shop. Website visitors or registered customers can select products from a list, add them to a shopping cart, and then create an order from that cart. Let's start. First, we have a list with registered databases for the advanced data generator. Then we click Create New Project. We select the database from the list and click OK. We'll enter a name for our project. Make sure to generate the data straight into the database and empty all tables before generating data. The next step is to visit the data settings for this project. As you can see, the top half here on the left shows the project objects. The bottom half shows the available database objects, like tables. The first table we will use is the products table. Let's select it from the list and click the Add button. Our products table will contain 1,000 rows, and we will make sure to empty the table before generating any data. Generating a fixed number of rows is the simplest setting of all. Now we'll enter specific data for each of the columns of the products table. The product ID is a simple sequential value. It will start at 1 and will increase for each new row. I will do this by using a template. I will select template from the drop-down list and then select the template from the available templates, sequence starting at 1. Next is the product name. I have prepared a list of product names. So let's generate a value from a list. In the generate drop-down box, I will select value from list. There you go. And here I can enter separate values that will be selected from. For this sample project, I'll just copy and paste these values in. Let's paste the values in here and append them to any existing values in the list. Let's click OK. The values from this list will be selected randomly. The Advanced Data Generator comes with a folder with sample product images. They are available via template. We'll simply select template from the drop-down list and the template product images. The price for each product will be generated randomly. We'll select random values from the drop-down box and enter between 50 cents and 250, rounded to 5 cents. Each product has a specific weight. This is required to calculate the shipping cost, which we will do later. The weight will be randomly generated between 100 grams and 25 kilos, rounded to 50 grams. Our products table is now finished. Let's continue with the next table, table customers. We'll select it from the list below and once more click the Add button. We will generate a fixed number of customers. And then select the columns to generate data to. The customer ID is once more the template for a sequence starting at 1. Customer names will be based on values from the data library that comes with the Advanced Data Generator. We'll generate a random value using a specific macro that takes values from the data library in a specific format. This button opens the macro editor. A customer name will consist of 2 parts. The first is a random entry from the first names library. Then it's followed by a space, and then another entry from the last names library. When you select a specific macro command, you can modify the details for it. In this case, I'll select an entry from the data library. Let's enter the space value here, and then we'll modify the data library value to come from the last names. We'll click OK to accept the macro into the macro box. For our email addresses, we will simply generate a random email address. For the address, we will construct another macro. Select random value, click macro and open up the macro editor. We'll use a street name from the data library, followed by a space, and then a numerical value. You've seen this before. You select the macro command and modify the details for it. A street name, a space value, and then a random numerical value between 1 and 2300, and we're trimming the leading zeros. Click OK to accept the macro. For the postal code, we will be using a template. There are several predefined templates. For generating Dutch addresses, we'll simply use a fixed value of NL. For phone number, we'll use a template, and the registration date will be a random value between now and all of last year. Our customers are now finished. As with products, we will make sure that the customers table is emptied before generating data. The third table will be the orders table. We will use this table twice in the project. The first order has the same date as the registration date of the customer. Additional orders can be created later on. We will add the orders table to the project, and because we need to generate the first order with the same date as the customer registration, we need to create a lookup. With a lookup, we can copy multiple column values for the same record into another table. As we need both the customer ID and the registration date from table customers, I will select a table lookup, check both columns, and click Finish. Now we will make sure that there will be orders created for each customer. Each customer will only be selected once. So I'll have to modify the lookup here. I click Finish, the lookup is modified, and for the method I will select all rows from lookup. This will automatically generate the same number of rows into orders as there are available customers. For the order ID, we'll use our template for the sequence once more. For the customer ID, we will select the value taken from the lookup customers. We'll select value from lookup, select the customer's lookup, and the customer ID column. For the order date, we'll have to make sure we select the registration date of the same customer. So we'll select value from lookup once more, and then select the registration date column. As we've used a lookup instead of a simple iterator across the customers table, the values for both customer ID and order date are always taken from the same customer record. The expected delivery date is based on the order date. From the Generate drop-down box, we will select Value based on Other column. We'll select the column from the Based on box, order date, and then add a few days and hours. In our web shop, customer nodes can be entered optionally. So we'll make sure to include nulls for this particular column. We will select random values, a single random paragraph, and include nulls for about 80% of the rows. Because customers can create additional orders with a different date than their own registration date, we will have to use the table orders twice in a project. We'll add it once more and the second instance is shown in the top half of the screen. By generating another 7,500 orders, we'll have a total of 10,000 orders for the customers. We can now enter the column details. Order ID won't be using the template because there's already existing orders in the table. So instead of using the template, we'll select increasing values. We start at 2501 and increase by 1 for each new row. Customer ID can be a simple referential link to table customers. No need to use a lookup now. As for the order date, we'll be using a random value between now and the next year. So we have 2 years of orders in our database once all data has been generated. For the expected delivery date, we'll do the same as before. We'll base this value on the order date and add a few days and hours. The customer nodes will be the same again, a random value, and include nulls for 80% of the rows. With the 2 instances of the orders in our project objects, we have 10,000 orders generated. Of course, orders need order lines as well. So let's add the order lines object to the project. Instead of using a fixed number of rows for the order lines or a random number of rows, we will generate order lines for each available order and then randomly set this between 1 and 5 rows per order. The reference to order ID will be taken from the master table. We select column value from master. The column order ID is matched based on name and will be selected by default. The order line ID is a simple sequential value that needs to be restarted for every new order. We will select increasing values from the list. Start at 1, increase by 1 and reset it for each master value in table orders. In the web shop, when you select a product from the list, the price per item and item description are copied. So we can't just set up a referential link to the products table here. We need to create a lookup as well, so we can get multiple values for the same product record. By creating copies of these values from the products table, whenever the webshop changes the price or the product name, the order lines will still reflect the original price and name. Records are taken randomly from this particular lookup. So for the product ID, we will select a value from lookup, link this to the products lookup, and column product ID. For quantity, we will generate a random value between certain boundaries. Select random value from the list. The price per item will be taken from the lookup. And so is the item description. All these 3 values, product ID, price per item, and item description are taken from the same products row. Now we've generated orders with order lines. Besides finished orders, there's also temporary shopping carts, both for visitors and registered customers. We'll generate those now. We'll create the shopping cart itself first. We've added a cart object to the project objects. We will be generating 250 shopping carts. Cart ID will be a random global unique identifier. Some of these shopping carts will be created by visitors who haven't registered yet, and some of these carts will be created by customers. So in some cases, we need a referential link to the customers table, and in some cases, we need this value to be null. Let's say that about 80% of these shopping carts are generated by visitors, so that means 20% is generated by existing customers. The shopping cart creation date is a simple random value. Obviously, these temporary shopping carts can include products already. Let's add the cart products table to the project objects. Let's generate a few rows in the shopping cart for each cart. The cart ID for this products line should be taken from the master. Cart line ID will be a simple sequential value, which will be reset for each master. And the product ID is a random value from the products table. This is done by creating a referential link. Quantity is a random value entered by the user. We've generated orders with order lines, temporary shopping carts with products added to them, and now we'll add something more tricky. We will add an additional order line to the generated orders that will calculate the shipping cost for all the products in the order lines for the order. We will do this by using a custom SQL statement based on the order lines table. Step 1 is selecting the order lines table in the available objects. Then we will click the Use this object as the basis for an SQL statement button. The SQL statement is automatically created, and if possible, the parameter data types are detected from the database. We'll give this SQL statement a name. This SQL statement is then added to the project object list. We will add an additional order line for each order, and the contents of this order line will be calculated based on the order lines for each order. We do this by creating a lookup. This lookup will allow us to run a query that calculates the cost and iterate over all the rows in the result set. I've prepared the statement, so I'm going to copy and paste it right into this box. Let me explain this SQL statement to you. As you can see, it will sum the weight of all products in the order lines table, grouped by different orders. And then will result in a 3 for the total weight above 40, a 2 for the total weight above 10, and a 1 for the total weight below 10. This is the basis for the shipping cost. Let's fetch the result set names and make sure that all columns in the result set are available to us in the Data Generator project editor. Now we need to process this SQL statement once for each row in the result set of the lookup. So let's make sure to do that. We'll select all rows from lookup from the method, and we'll see that the lookup is defined as to be sequential or unique. We can modify the lookup and make sure it is defined as such. Select mode will be unique, so each row in the result set will only be used once to be processed for the insert SQL statement. By using all rows from a lookup that's defined as to be unique, we will process the custom SQL statement once for each row in the result set of the lookup. This should be familiar to you. The order ID will be a reference to the order ID in the result set of the lookup. The order line ID will take a fixed value instead of the sequential value. It will simply enter 999. The product ID will stay empty because there isn't a product for this. And the quantity is based on the lookup, as the quantity of times shipping cost will be calculated in the SQL query. We will use a fixed value as the basis for the shipping cost, and the total shipping cost will be this value times the quantity calculated in the SQL query in the lookup. The item description for the line for the shipping cost is a fixed value. Obviously, we can't enter the table here because this is an SQL statement. And let's just check if we are emptying the correct tables in the rest of the project. Because we're using the orders table twice, it's only emptied on the first instance. If all is well, we've now created a sample project for the advanced data generator on the sample database. This project shows you several techniques that are available in the advanced data generator. I can either click OK and save the project and start generating data later, or start generating data immediately. Let's execute this project so that the data will be generated. You can see the different items in the project being processed. The products table, the customers table. The orders table is processed twice. First to generate the orders with the same date as the registration date of the customers, and a second time to generate any additional orders. Next are the order lines, 1,000 orders with 1 to 5 rows per order. And the final item is processing the shipping cost. There you go. All rows have been generated and the data is now in the database. I switched to a different application called Database Workbench to show you the data generated. Let's open the data in table customers. Here you can see the different customer names taken from the data library, or the email addresses generated, and even the addresses. They look like normal addresses in the Netherlands. Here's the products table with products generated with values from the list. And here's some sample product images. Here is the data in the orders table for you. As you can see, some of the customer notes have a single paragraph of text, others are empty. Let's take a look at the data in the order lines table as well. Order lines are ordered by order ID and order line ID, and in each order you can see that order line ID is a sequential value, and the final order line with the shipping and handling has an order line ID of 999. Do you remember that we've created between 1 and 5 order lines per order? Here you can see that different orders have a different number of order lines. We did the same for temporary shopping carts. And here you can see that some carts have one item added to it, and some cards have multiple items added to it. This is just some of the data you can generate with the Advanced Data Generator. I hope you got an impression of what it can do for you. You can generate data for presentations, for volume testing, or for other testing purposes. You can also generate data for data exchange projects. Take a look at the documentation and this comprehensive how-to section, and you will know how to generate data for your specific purpose. Thank you for watching.